Okay, take two of this lab report because the first time the audio didn't go. So this is lab 5 for physics 2211, and my purpose is to determine the coefficient of static friction of my laptop, and my laptop is an HP Envy X360. So I googled like what it's made out of, which is aluminum and plastic, and the coefficients of friction of those, which is aluminum is about zero point 0.6, and plastic can range from zero point 0.2 to zero point 0.6. Um, and then there's no computational model because this is just friction, and I'm not changing the objects or the incline. This is only to determine the static friction. Um, so key physics concepts is static friction, which is the force that opposes the starting of motion between two surfaces that are not already moving relative to each other. Um, because I'm looking for the maximum, which is right when the object begins to slide rather than kinetic, which I would have to like video it and analyze that. And then this is my free body diagram, which has gravity, friction, and a normal force on it. And the incline is at the angle that we find from the actual experience. So the methods are to place my little stuffed animal Bella on a closed laptop and measure the length. There's an app on iPhone that measures lengths, which is pretty cool. So then I tip the cover up until Bella starts sliding down. And I used my buzz card for a straight edge there, so I know the picture looks like I measured some random wherever I wanted, but there was a straight edge there, I promise. So then I measured the height of that, and from those calculations, we can calculate the angle it was at. So this is a summary of the forces that are present, which is gravity, normal, and static friction, and the directions they go and how to calculate them. So this is my work to find the angle of incline. Yes, I use freedom units, but trig is a ratio thing, so it doesn't matter. But we've got opposite is 4.5 and adjacent is 9, so arctangent of 4.5 over 9 is going to end up with theta being about 26.565. To calculate F net of y, um, gravity perpendicular and normal perpendicular cancel out because they're both mg cosine theta. And then to calculate F net of x, this is right before Bella starts sliding, so we're in equilibrium, so F net of x equals 0. And then the components are gravity parallel and friction, which is going to be mg sine theta minus coefficient of friction mg cosine theta because friction is often acting in the opposite direction. When you rearrange that, you end up with just tangent of theta, which is 0.5. So the expected coefficient was about 0.6, 0.2 to 0.6, so I'm pretty happy with 0.5 as my answer. Possible errors, include incorrectly assumed coefficients of friction. When I looked up the materials of my laptop, their website said it was just like recycled plastics and some metal because they were pushing the whole sustainability thing with the ocean. And so I just looked up plastic in general, which is why that was such a range. And then some what if questions I came up with was what if Bella was heavier or made out of like silk? So the first part is actually a trick question because the mass doesn't matter as you saw in the calculations because mass and g both cancel out. So if she was made out of silk, she would have slid sooner, I think, because silk has a very low coefficient of friction because it's smoother and it would just go faster. And so I think it would have started sliding at an earlier angle. But yeah, that was lab 5, the last one, and I'm really happy about that. And if you're actually listening to me yap, like, I don't know, cool.